Hello guys, welcome to Edustart now. I am Kamlesh and I work for Amazon. And today, in the previous session, we have discussed about what exactly NLP and what is the process of NLP and things like that. And in this session, we'll try to understand what is CNN and what is CNN and neural networkings and how exactly the deep learning works in a bigger picture. So, to continue today's session, if you haven't subscribed my channel, please do subscribe to it. And if you have any doubts, please mention the doubts in the comment box. Okay. So, and if you haven't follow us on Instagram, please follow us at Edustart now. So let us continue the today's session where we are going to learn about what exactly the plan of attack on CNN. Okay. So the core syllabus of today's topic is what the neuron. So in this session, we'll learn the following things. That is, first of all, we'll talk about the neuron. So there'll be a little bit of neuroscience, and we'll find out about a bit about how human brain works and why we are trying to just replicate that. So we also see that the main building block of a neural network and the neuron new looks like. So then in the next tutorial, we talk about the activation function, and we look out a couple of examples of the function which we could use, and we'll find out which ones of is the most commonly used in neural networking, and in which layers would you rather use in which functions. Okay, so then we also talk about how neural works with an example. So what you expect was probably conveyed in other courses and tutorials. We are not going to go into the learnings, we are actually going to the workings of neural networks first, because that's where, by seeing a neural network in action, that will allow us to understand what we are aiming towards our goal is. Oh, here look at examples of a neural network work. Look at a very simplified and a very simplified hypothetical where your own hypothetical, so where you have to predict the housing prices and the real estate price and things like that. So looking at that example, by looking at that example, we'll better understand what exactly we are aiming towards and what we are wanted to achieve in end. And then we'll move on to understanding how neural network learn, because that will be more prepared for what's coming. Then we talk about the gradient descent. This is also the part of neural networks learning, and we'll understand how that algorithm is how the algorithm working and understanding for the Bruce force method that you might be interesting or willing to take as a first resort or first. We'll talk about sarcastic gradients and gradient descent. It's a continuation of the gradient descentations, but it's even better and even stronger method, and it works very well. So finally, we'll wrap up the things by mentioning the importance of back preparation and summarization of everything in a step by step. So we're running an instruction for an artificial neural networking. So this sounds very exciting to you, because I am also very exciting about. I can't wait to get in started. I I look forward to see from the next slide. It's a very interesting. So if you haven't subscribed the channel, please do subscribe to it. And we'll start from the neuron. Okay, so what exactly the neuron is, how the neurons exactly works. So which is a basic building of artificial neural networking. So we saw an image, we are seeing an image like this. So this is actual real life neuron, which is also smeared into the glass and colored a little bit, and they are observed through a microscope. Okay, so this is what they look like. So this is an interesting structure, and lots of different kinds of branches are coming out of them. Okay, this is a very interesting. But the question is how we can recreate the machine learning. So we really need to recreate it, and since the whole purpose of the deep learning is to mimic how the human brain works, and in the hope that by doing so we are going to create something amazing. We are going amazing infrastructure for the machines to be able to learn. So why do we hope for that? because human brains is just what happens to one of the most important powerful learning and tools in our planet or mechanisms on the planet, and we just hope that if we recreate that we have something and awesome as that. So our challenge now, then the very first step to create artificial neural network is to recreate a neuron. How do we do that? Let us have a closer look of what exactly the neuron looks. So this images was first created by Spanish neuroscientist in the year 1989, I guess, if I'm not wrong. So what he did is he died in a neuron actual brain tissue and look at under a microscope. And while he was looking at that, he actually draw what exactly how the neurons look like. So which have all these large neurons branches coming out of them towards the part, and each of them had a or out like a thread coming out towards the bottom of the very long one. Okay, so that's what you saw, and now the so technology has advanced a quarterly. We can see neurons such a close in a more detail, and now we can we draw what exact looks like in a dramatically. So this is what the neuron it looks like. Very similarly, look like whatever the scientists which have been drawn. So this neuron, what we can say, it has got a body, and that is the main part of the neuron. And then he calls some branches. Branches is called dendrites, and this is called axon, and a long tail on the neuron. And so, what are these dendrites with a foreign or axon as well? The key point to understand here is neuron by themselves are pretty much useless. Okay, it's like an ant, and ant on its own by can't do anything. So five ants together can pull something or drag something. So they can't build an ant here. So they can't established as a one unit. Okay. So but it is in a group. It definitely works on them. So we have a million hands. They can build an old colony and also can build with a colony. So you can also strong, but you have a lot of neurons together work to. So let us understand how do they work us. That's what the dendrite and axon do. So dendrites are the kinds of receivers of the signal, and axon is the transmitter of the signal for the neuron. And here the image how works conceptually how it works. This is the neuron. Its a dendrites are connected to axons of the other neuron, and these are the receptors. Yes, the signals of on it travels down its axon and connects or passes down to the dendrites of the next neuron, and that's how they are connected. And the small image there, you can see that there is an axon. Axon doesn't actually touch the dendrite a lot, but machine learning and a few machine learning scientists are very adaptable for that. Okay, it doesn't touch and things like that. So better to understand in a very big picture, it has been proven that there is no physical connection over there, but the point is very interesting that the connection between them, the whole concept of the signals being passed, that is recall and sign up. So you can see over there a little image that that we can figure out in the back end, and that's a term we're using. So instead of calling artificial neurons the lines that we are going to have or connectors for dendrites, because of then the question is who is connection is that who is this neuron are networking and how which neuron is networked with another one, and that's kind of answers all of a just question in. So basically the signal is passed, doesn't matter who element and which element that's passed to. So just a representation of a signal pass, and we have seen just now. So basically that's how the new neuron works. And let us move on how we are going to represent a neuron going to create a neurons in a machine learning. So we are moving away from neuroscience and getting into the technology of machine learning. So here we go. So this is our neuron and something which is called as a node. So these are the input signals, and it has an output signal. So dendrites and axon, remember we are going to call the synapse, and then these inputs this input we are going to represent them other neurons as well. So in this specific case we can see that the neuron is the green neuron is getting a signals from yellow, and in this course we are going to try and stick to codecodon regime where yellow means an input layer, whole neurons on that layer, outer layers of the signal. Okay, So it would be like like kill to call the signal is basically an input value. So you know how it's simple in a linear regression we have input values and then you have a predicted values, and you have input values and there is the yellow ones are, and you to right you'll be see the output value. The thing that I wanted to point out here is that a specific example we are looking at the neuron which is getting signal from input layer neurons. So there is also neuron, but they're input layer neurons. So sometimes you'll have the neurons which get their signals from hidden layer layers. So from green neurons, and the concept will be the exactly sense. In this case, for simplicity sake, we are putting up. And in terms of input layer, we think about what it is in the in analogy of the human brain. The input layer is the sense. So whatever you can hear, feel, touch, and smell. And of course, it's like lot of things you can see coming information. So that's what your brain is limited to. It's pretty much like it's pretty much a box of bones, and just as such, just like a mind blowing concept to think. It's a very big topic to discuss. So we can't hear and see. We can only get electric impulses from these organs that you have to, which is called ears, nose, and eyes, and touch, and whatever your taste and feel. So it's just like getting signals, but it basically lives in this dark black box and is making sense of the world through a senses. It's a phenomenal. So and yeah, so these have you have these inputs that are coming in the terms of human brain. Yeah, those are the five steps in the terms of machine learning and deep learning. That is basically your input value. So independent variables, and we get a second. And so our input values, they are similar as pass through. So they passes the synapses to the neurons, and then it passes through the output. In this specific terms, yellow means the input layer. We can simplify, and then we will saying only have the input layer, and then we are going to have one hidden layer, which is a green, which is a hidden layer, and we are going to put it out away. So just we can use the switch which can be called for us now. So there we go. That's a basic structure. So now let's into big more detail about these different elements that we have. So we got the input layer like this. So what we have here, so we have these inputs which are in fact which are dependent variable. So dependent variable one and dependent variable two. So important things to remember that are these are independent variable. So these are all for all independent variables. So one observation, you just take all the independent variables, that may be its age of a person or else money in the bank account and things like that. How do they drive walks, so how do it walk from, so how the shampoo is protected. So this is all a description of the one specific question that you are either training your model or performing some predictions on that. So and that is other things you need to about this variable is you need to standardize them. So you need to either standard them, which makes the mean if zero and the variable is one. So you can also sometimes be land up per point of these traces in a bit more detail. Perhaps in the practical terms you might come across this. Sometime you want to know what exactly the standardized might mean, and you want to normalize them, meaning that instead of making sure the mean and the very variance is one, you just take, okay. So minimum values minus minimum by the range. So round of the values. For that you get the difference between 0 and 1. And it depends upon the scenario. You might be wanted to do other, but basically you want all these variables to be quite similar in the about the same range of values. And why is that? We all values understand go into neural network, as we'll see just now. They will be added at a multiple multiplied by weight, and just going to be easier for the neural network process them if they have all about the same. And in fact you know that's how the properly able to work. Okay. And if you want to read more about the standardization, normalization, and other things you can do is variables is good reading, additional reading about the things like uh, and so young, hold on for a second. So let us understand what exactly y and y output value. And now let's move on one more point to realize. Just wanted to reiterate about the thing. So on the left we have single observation on one of your mean from the data set, and right have a single generation as well, and that is the same observation. Okay, important to remember that, like whatever the inputs you are trying to put, that is for one row, and output is for the exact row. If you're training the neural network, then you know you are putting the inputs in for one that role, you are putting output for the other role. So you kind of simplify the complexity things. Think as a simple linear regression or a multi-regression linear regression. So you're putting all your values, you have the output, and this is like there is no question about it. So there is no question about things like regret. We are used to it. So something there is no too complex getting putting the value. So just remember that every time it once row you're dealing with, so you don't get confused and start putting like these are the different rows and putting it into your artificial neural network and something like this. All the values in a row and the different observations are different. So different character features about relate to that one observation in every single time. So next thing we want to talk about is here is the ups and down signs that we gonna. Uh, so here we have got it the sign in, so we have to assign the weights. So we are going to talk more about the way further down, but the short weights are crucial to artificial neural networks. So weights are how the neural networks learn. So by adjusting the weights, the neural network decides how important what thing is important, what's not important, what exactly passed and what does not get passed along, what strength to what extent signals get passed along. So weights are crucial. They are the things that get adjusted through the process of learning. Like when you're training artificial intelligence network, you are basically adjusting all the weights and all the signs across the whole neural networking, and that's where the gradient descent and back propagation come into play. So those are the concepts that we also discussed, and so basically those are the weights. That's all we need to know as of now. And we have got the neuron. So signals going to neuron and what happens in the neuron. So this is the interesting part. We are talking about the neuron today. So what happened inside the neuron? So a few things happen. So the first step of all of these values, and it's getting added up. So it adds. So add this aggregated sum of all the input values and getting very simple. So it's very straightforward, just adding up the multiple by the adding up, and then applies an activation function. So we're going to talk more about the activation functions further down, but basically it's a function that is assigned to a neuron or whole layer, and this is apply and it's applied to the weighted sum. And then from that you don't understand, it need a signal to it needs pass on signal if you like, and that the signal the passes to the functions apply to the way that some. Okay, that basically depends on the function. The neuron will either pass on the signal or it won't pass on the signal. So that exactly what happened in the step 3. So the neuron passes all the signal to the next neuron down the line. Okay, that's we want to talk about the next slide. So this is a very important topic. So what are the steps which have been included? So let us understand what exactly the activation function is talking all about. Okay, so let us continue the activation function. So how the activation functions will be applied and things like that. So this is a very important topic. So activation function. So on the very first thing, if you talk about activation function, there are more different types of activation function, but these are the predominant ones you are trying to hear. And this is a threshold. This is a threshold function. So this is a threshold function. This is how it looks like. So on the x-axis, you have the weighted sum of inputs of y, and y-axis you have the basic threshold of 0 to 1. And basically the threshold function is very simple type of function where if the value is less than 0 then their shell function pass it on to 0. If the value is more than 0 or equal to 0, then the threshold function passes through 1. So basically it's a kind of yes no type or a function, very straightforward. very rigid type of function, either yes or no, no other options. So there you go, that's how it works. Very simple function. Let's move on to something a bit more complex. This is a sigmoid function. Very interesting formula we have seen. We have seen that, yeah, there is a 1 divided by 1 plus e to the power of minus x. So in this case, of course, x is the sum of values and the way of the sums. Okay, and so yeah, this is what the sigmoid look like. It's like a used function in the logistic regression as well. If you recall that from machine learning subject which we discussed. So the good thing about the function is it is smooth, unlike the virtual function. This doesn't have like kings and curves, and therefore it's just nice and smooth and gradual progressions. So anything is below zero, it drops off of zero. It one sigmoid function is very useful in the final layer in the output layers, especially when you're trying to predict the probabilities. Okay, we'll see that through in this course. And we have the rectifier function. The rectifier function, even though it has just a slightly high kink, but one of the most popular function for all the artificial neural networks. So it goes all the way to zero, and it's a zero, and then from there gradually progress as input values increase, as well as we see that throughout the course, the intuition of the tutorials will also see that how we'll use this rectifier in the practical scenario. So if you have any doubts, comment in the comment section. So just remember, the rectifier function is one of the functions useful in artificial neural networks. And just finally, the last one, we have hyperbolic tangent function. So it's very similar function. It's very similar to signal function, but here the hyperbolic tangent function goes below zero. So values from 0 to 1, or approximately 2 to 1, and go from 0 to -1 on the other side. And that it can be useful for some applications. So we are not going to into too much depth on each one of these functions. Just wanted to acquire just what exactly they look like and what they are called, so that would be easy for you. So if you want to get additional reading, so check out some of the papers which I read by Zairier, and I link that in the description. So there are 2000 papers. They'll well exactly why the rectifier function is such a valuable function, why it is so popularly used. But I would never left for now. You don't need all these. But now you are going to start applying them, which is can be used more and more. So when you feel comfortable with the practical side of things, then you can go and refer to this. Okay, then you'll be able to soak in the knowledge much quicker, and that will make much more sense. Okay, but just keeping this in mind, when you're ready, when you feel that you're ready, then you can go and refer the some of the papers and get some valuable information from like a source like Medium. Okay, so let us recap once again. We have threshold function, we have sigmoid achimoid function, we have rectifier function, and we have a hyperbolic tangent function. So now to the let's continue the important tutorial. We'll complete the few exercises. So just let us understand what exactly. So first example, we have a neural networking is one neuron and other is output layer, and the question is assuming that your dependent variable is binary, so either 0 or 1, which threshold is would you use? Out of the ones we have discussed, we have threshold function, the sigmoid function, and the rectifier function. Okay, so which is the step we're gonna use? So in the row forms, which ones would you like to use for a binary variable? So this is a binary variable. Answer is here. The two option, that is if threshold function, if threshold so is the activation function, because it is, 0 and 1, it can be 0, and otherwise it can be 1. So it has only two values, so it fits perfectly. If there is a sigmoid function, if there is a sigmoid function, then that could say y is equal to threshold function. The threshold function of sum And then in the second case which you put is a sigmoid activation function. So it is actually between 0 and 1 just to be what needed, but at the same time you wanted just right, so not exactly what we needed in this case, but you could leave in this case you can use as a probability of being y, yes or no. So we want to be y to be instead sigmoid function. Sigmoid activation function tells us whether it could be a probability of y being to equal to 1. So basically you get closer to the top of more, uh, that is what it is needed for 1 or no, so rather yes or no, and that is similar to the logistic regression approach. And these are the two examples if you have any binary variable. Okay, now look at another practical application. Let us how old this gonna play. So if you have any neural network, like how do this gonna play? So in the first thing we have output input. So first we'll send to the first hidden layer, and then activation function is rectified. And usually we like try to we would apply a rectifier activation function. It will look like this. So we'll apply rectifier function, and then the signals would be passed on to the output layer, and where with sigmoid function will actually apply in it. That output be the final output, and that could be probable, that could predict the product probability of the combination. So in the hidden layers we apply the rectifier function, and the output layers we applied sigmoid function. So yeah, there we go. Hope you enjoyed this tutorial. So by this, you can able to understand what exactly the functions. So how the sigmoid function, rectified function, hypotangent, and where to use activation function and when to use sigmoid function. You have handful knowledge about that. So let us understand what exactly how does a neural network works. Okay, see the real example of how the neural of the NNSS works. So we are actually going to work on the step by step through the process of application, and we know that what's going on. So let's have a look what example we're talking about. We are talking about a property evaluation. So we are going to look at the neural networks that take some parameters of a properties and the values of it. And the thing is here, there is a small event for the today tutorial, and we are not actually going to train the network. So very important part in neural network is training up them. So we are going to look that in the next tutorials in this session. So now we are going to focus on actual application. So we are going to work with a neural network that we are going to pretend is already trained up, and that has allow us to focus on application side of thing, and not get broke down in the training aspect. So we cover the training part when we already know what are the goals we are which we are working for. So all right, let's jump straight into it. So we say there sorry let's say we have some input parameters like four parameters like area and square feet as bedrooms, and we have the distance to the city miles, and we have the age, and all of those four inputs are comprised of our input layers. Now, of course, there are probably way more parameters than define the price of the property, but for simplicity, say we are just take less these four. So very basic form of neural networks. We has an input of layer of input and output layer. So no hidden layers. Okay. So output layer is also there is a price for that. In this form, what's these input layers variables are doing us. So these are weighted up by the synopsis, and the price that would be calculated on basically the price which is being calculated. So price is equal to W1 weight 1 into 1 weight 2 into 2 and weight 3. So weighted sum of all input, and here you can use you can use a pretty function. So here you can use a pretty much function. So you could use, so what we're using now is an activation function, and we have previously could use logistic logistic after that. So you could also use a square functions. You can do pretty much anything here, but the point is you'll get a certain output. And moreover, the most of the machine learning algorithms that exist can be presented in the form of so this is basically a diagram of represent how to deal with the variables by changing the ways formulas it can accomplish a quite lot of machine learning algorithms which we have talked. So before and put them into this form, and that's how the powerful neural networks are. So even the how hidden layers were ready to representation for the most of the algorithms that work. So neural network, we have an advantage that gives a flexibility and power within with which where the increase in accuracy comes from. So and the power is hidden layers, and they are and that's our hidden layer, and we add it in now. So now we understand the hidden layers gives us the extra power, and so in fact we are going to walk through and examples. So we agree that the neural network has been retrained up and going to plug in. We are plugging in the property. We are going to walk step by step through the how the networks will deal with the input variables and calculate the hidden layers and calculate the output layers. So let us go through this. So we got all the four variables to the left, and first we type with all neural network on the hidden layer. As we saw in the previous tutorials, all the neurons from the input layer have synapses connected to each one of them to the top neuron in the hidden layer, and those intersynapses has weights. So let us agree that some weights have a non-zero value and some will have zero value, because not all inputs will be a valid or not all the inputs will be important for every single neuron. Sometimes inputs will not be important. So here we can see the two example like x1 and next 3, the areas and the distance to the city and miles are important for the neuron, but bedrooms and age are not at all important. So let us understand what exactly how the case would be. So likewise, the neuron will be linked to the areas and the distance, but does not mean that could be anomaly further way yet from the sea to the deeper area that becomes. So therefore, the space become of the property is larger. So same price you can get a larger property further where you can get from the city. That's normal. That makes sense. The probably what is neuron is doing is looking specifically like synapse sniper. It is looking for area properties which are not so far from the city but have a large area. So for their distance, the city they have an unfair square foot area. So write something abnormal. Height is higher than the average, so they are quite closer to city, but they are large. So suppose the other ones are the same distance. So that neuron again we have speculated that the neuron might be picking a laser picking up those specification properties, and it will activate. Hence, activation function will activate. It will fire up only when the certain criteria is met. That the distance and the area of the property and the serene area of the property, and it performs on the calculation itself. It combines those two as soon as certain areas fire ups and contribute to the price of the output. So therefore the neuron doesn't really care about bedrooms age and the property because it is focused on that specific thing. That's where the power of neuron comes, because you have many of these neurons and just you have seen now. So the place we don't cluster our image as so just we know exactly what exactly the neuron is focused and the area and the distance to the city. So always we are agree on that. Let's move on to the Nagam. So let us take the one in the middle. So here we have got three parameters feeding into this neuron. So we got the area, bedroom, and the age of the property. So what could be the reason here? Let's try to understand the intuition and thinking of this neuron. Neuron. How is this neuron thinking? Why is picking these two parents? What it could be hit like found in the data. So we are already established trained up data set and what is happened a long time ago. So day ago. Somebody is applying. So somebody is ready up, so we are just applying. So this neuron they find out the area plus the bedrooms plus the age and combination of those parameters are important. Like would be the case. So instance they maybe in a specific city those suburbs or neural network has been trained in the into perhaps the lot of families these with the kids who have two or more children who are looking for large properties with larger bedrooms which are new. So not all poor properties, because maybe in that area most important or kind of a big properties are usually old. There's a lot of modern families that maybe the demographic so shift maybe, or maybe there's been like a lot of some growth in terms of employment and jobs for the younger, for the younger cell phone. So just like the population demographics have changed, and now the younger couples or younger families are looking for the property, but they prefer the property, so they want the age of the property to be lower. So hence the training from the neuron net has undergone. It knows that the property is a large area with the lots of bedroom and last of three bedrooms for the parents for the first child, and at least three bedrooms, maybe a guest room for the properly with a high area and lots of bedrooms is valued in the market. So that the neuron has picked up. It knows that okay, this is going to be a looking for, I don't care about the distance of the city miles, whatever, as long as it high area, lots of bedroom, as soon as that criteria is met, the neurons files up, and the combination of these parameters are this is where the power of neural network is coming, because it combines these three parameters into a brand new parameters with a new attributes that helps in evaluation, with the evaluation of the property. So it combines the two attributes, and therefore it's more precise. So that's how the neural network works. And let us look at another one. Let us bottom. So this neuron could happen if it just one picked up one parameter. So age. So do not put any other. How could that be a case? So well, the classic example when the age could mean like, as you all know, the older properties it's less valuable because it were and out, the building is old, probably the things are falling apart, more maintenance is required, and the price drops in terms of price of the real estate. So brand new building, it would be more expensive because it's a brand new, but perhaps the property is over a certain age, that could indicate the historic property. For instance, if the property is 100 years old, then the older is less valuable it is. So, but as soon as it jumps over 100 years old, and suddenly it becomes historical property because of this is a property where the peoples have still hundreds of years ago. It tells a story, that's all. It's history behind the people, and some people like that value. It's like a lot of people would like to proud to be live in a property, and especially in the higher social economic classes, they would show up their difference and things like that. And therefore the properties over 100 years old could deem to as a historic. And therefore this neuron, as soon as sees a property over 100 years, it fire up and contributes to overall prices. And otherwise, if it is 100 years old, then it won't work. This is a good example of rectifier function to be applied. So here you have got a rectified function like, so like a zero until the certain point, and after 100 years old, the higher the contribution of this neuron to the older price. And this is a wonderful example with a very simple example of a rectifier function in action. So there we go. That could be the this neuron. And moreover, the neural network could have been picked things that we would have thought ourselves. So, for instance, a bedroom plus distance, the city, maybe there's a combination of how to contribute to the price. So maybe for the some neurons, and it contributes. Maybe it retracts the price. That could also be the case, and other things like that. So maybe you added your own combination of four of these parameters and see the neurons, that these neurons is whole hidden day situation allows you to increase the flexibility of your neural network, and allows the neural network to look in for a specific things, and then combination. So that's where the power comes from. It's like the example like, add by itself cannot be beaten ant hill. So, but when you have thousand or hundred thousand ants, so you can build a ant hill to them. That is the situation. Each neuron can be built. So together they have superpower, and they predict the price, and that have to do a quite an accurate job. Sorry, a quite an accurate job if they have given it train properly. And that's what whole course is all about, in understanding how to utilize them. So that is step by step work through about how neural networks work. Fundamental approach getting the program what to do and what you want to do. One is a hard coded coding, when you actually program for specific rules and what the outcomes you want, and you have just guide through the possible whole way and account for all the possible options that the program has to deal with. So on the other hand, you have a neural networks where you create a facility for the program to be able to understand what it needs on its own. So you basically create the neural network where you provide inputs and you tell what you want to as an output. So then you let it figure it out its own. So two fundamental differently approach, and something to keep in mind as we go through these ideas. Our own create to create the network which learns on its own. So we are going to avoid trying to put the rules, and a good example that I can give you on right now is this. This will come in the further in the course, but less to visualization example I would like to give. So how the distinguish between a dog and a cat. So on the left side of the process is deprecated on the left. The program thinks that cat ears have been like to be licked, and look at for whiskers, and look at like this type of nose shape, the face look of these colors, and would you like to then would like to understand the conditions like the ears is pointy, then the cat if the ears are sloping down, and possibly dog and so on. So how then the neural networks the neural network, you just code the architecture, and then you point the neural network at the folder with all the cats and dogs with the images of cat and dogs which are really categorized, and you tell them, okay, I have got some images of cat and dogs, so go and learn what is cat is and go and learn what a dog is. And the neural network will on understand and needs to understand, and then further down the train, when you give a image of cat or dog, it able to understand. So there they are, those are the two fundamentally different approaches, and today we are going to start working into how the second approach works. Right, so let's get straight away. So here we have a very basic neural network with a one layer is called a single layer and a feed forward neural network, and it also called as a perception. So before we get into one thing, we are just what is the output value, and right now you can see that it's just a y. We need to put a y hat in there, and reason for that usually y stands for actual value. So y is going to be the actual value which we see in reality, and y output values are predicted value by algorithm by the neural network. So what is the output value? So y is output. The basically the denomination of the output value, and the perception y invented in the 1957 by Frank Robert. So whose idea was to create something that can be actually learn and adjust itself. So this is what where we are going to look at now. So now we have got a perception drawn. So let's see how the perception learns. So let's say some we have inputs values we have been surprised to the perception or basically to our neural network. Then the activation function is applied. Then is applied. We have the output. Now we are going to plot an output on a chart. So there is a y hat and we have y. So what we need to do in order to learn, we need to compare output value y hat. So we want to neural network to work and get right. So and that is a value y, and so you'll be see a difference. So now we calculate what functions cost function is one half of the difference of the square difference between the actual and output value. Now there's many ways you can come up with a class function. So there are many different class functions you can use. So this is probably the most common use call function, and why specifically this function they use that. So we use a further download to taking the gradient descent, but now for just going to agree that this cost is a function. So basically what the cost function is telling us what exactly the error, and you have prediction. So our goal is to minimize the cost function, because the lower the cost function, the closer the y hat is to y. So okay, let us agree on the let's proceed. So basically we are from what happens is the cost function, and here what happens now is we going to compare what the feeded information back into the neural network. So there we go. The information going backward into neural network and goes that goes for the weights. Weight gets updated. So only the weight we have to control is the weight. Very simple neural network are the weights. W2, W3, and Wn. So the our goal is to minimize the cost function. So we can do is update the weights. So update the weights and tweak them a little bit, and how exactly we'll find out for the weight. So now we are done with the weights. So we continue. But here I put a screenshot where the data just that to make some points very clear that right now throughout the whole experiment everything we are doing right, but we are dealing with just one role. One we have data, so we have one row. So for example we are dealing with how long you study. The variable they are predicting is what the results are getting in exam, and the dependent independent variables that we have is how many hours did you study for, how many hours you sleep, and what did you get on the quiz, and semesters and percentage where did you get. So basically, those variables you are trying to predict what score you'll get from the exam, and the exam the 93% that is the actual value. That's why. So that we feel these three values in a neural network again for the second time, and then we are going and then we are going to comparing the results to white. So let's see how it works. So we see these values into neural network, and everything gets adjusted, and we can see weight. You can see the weights have been adjusted. We can feed the values, and the point is we are feeding in same ball. So we have only one role. We are trying to do a training one role. This is because it's very simple, basic example. Then we see what happens. There is morals. So again, we feed these rows in a cross functions and get it gets adjusted. As you can see, everything upon the along the those lines again. So as you say, every time the VAT hat is changing because we have weakened the weights. Y hat is changing, a cost function changing, and look again how those are feeded in. So those feed those in, white hat is changing, cost function is changing. We get information back through weights, so that weights get adjusted again. So we feed in the same thing and adjusted goes back to the weight, and one more time we feed in. Okay, and another time we have adjusted the weight just because we feel that information, and there we go. So white hat is equally to y cross function 0, and usually you don't cost function equal to 0. But this is a very simple example, so hopefully you have made a sense that we have feeded the exact the same row, because just in case you're dealing with that one row into our neural networks. Well, the weights get into the value, so the valid supply of the weights activate function will happen. So we get y hat is compared to y, and then see first of all the first function is change feedback of the feedback information neural network and just adjust the weights. So then we repeat the same process again and again with the same exact row, which we try to minimize the cost function. So until now we have been dealing with just the one row. Let's see what happens if you have multiple rows. So here the first full data set we have 8 rows, and how many hours you have slept. Maybe these were the different students in the day taking the same hours of how many hours they have studied and how many hours they slept before the exam. That would get we get on the quiz and the final result on the test. And as you can see here at the left, we have 8 of these perception actually. They are all the same perception, so this also is important. So a multiple or duplicated 8 times so that we can um, conception is that the important thing is here same neural network we are going to feed these into the same neural network. So let's get started. One airport is you here has been mentioned. One epoch is when we go through a whole data set and we train our neural network on these roles. So these are list up. So these are first row, and there is y hat for the first row, and second row, and this y hat for the second row. So it's fair enough into the same neural network. Every time we just copy them several times so that we can visually see how this is happening. So then it's happening third row, and then it is fourth row, and this is fifth row, and so on. So basically, we get the same remaining values for all the four values. And every time it is filling the row into the neural networks, we get we get about it. So then we compare the actual value. So they are the actual values. We try to compare if everything values and we based on the differences between y and y hat, we can calculate the cost function, which is the sum of the squares. That so uh, so y hat and y hat of this. So there is a cost function which has been related, and basically now we are after the fully cost function, we have to go back and update the weights. So update like W1, W2, W3, and W3. An important thing is to remember is this: all of this perception of all these neural networks is actually one neural network. There is not eight of them. There is only one. And we update the weights when we're going to update the weights in the neural network. So basically, the weights are going to be the same for all the rows. So it's not the case that all the row have its own weight. So all the row shares the weight. So that's why we looked at the cost function, which is the sum of the square difference, and we updated the weights, and now then we have one iteration. So next we are going to run this whole thing again. We are going to feed every single row into the neural network and find out the cost function and do this whole process once again. So let us we saw the previously where we have one row everything and again. So here things will be, but we are going to be for 8 rows, 800 rows, and however how many rows you have in your data set, and you do the process and then calculate the cost function. So the goal is to minimize the cost function and to get as soon as you found the minimum cost of the function, and that is your final neural network. So that is the weights have been adjusted, and you have found the optimal weights for these data sets. So you began your training. You began your training ready to proceed to the test phasing or the application phase. So this is whole process is called back propagation. So some additional reading that you might want to help for the cost function. We have just lead through one many different ones. So it can be article, you can look at it in the cross validations and things like that. It's called the list of cost function used in a neural network along with the application. So neuro is there, but you can just google up for the search exact search term like search phase, and you will you use one the first one that pops up. It actually got some good examples and application for each cases for the different cost function. So if you're interested to learn more about the cost function, check out these articles. And that note, if you would like to listen this thing. So up till now, I hope you are very much cleared about that. So let us discuss gradient descent. So this gradient descent, this is a input value, this is a weight value, and this is the output. We actually calculate the function for it, and this is a curve where we just if we wanted to plot it down, what exactly the curve and what exactly the data points of it. If we try to plot a cost function of it, and this is a formula. So half of y hat minus y whole square, if you try to jot it down, this would be the best, yeah, a u-shaped curve which gonna be displayed over here. So the best line among the best point and exact median is taken by for calculating. So this is known as a curse of dimensionality. So any number of data points like area, bedroom, twin cities, and this thing has been calculated with the hidden layer, and with that hidden layer then the output of y is taken. So the example, they have 25 weights. So so they are example of 25 weights. So instead of one hidden layer, they try to induce several input layers, like input layers, and these are the hidden layer 1, hidden layer 2, hidden layer 3. So by doing this, we can get a maximum amount of we get the best and equal parts of output. So that could be minimum in nature. So the output layer is maximum among all. So if you understand a cost function, if say suppose the point is here, and in the next slide I would like to explain. So this point is the first one, and the point adjacent to approaching towards the cost function is this one. So this one, and end of the cost function will come and sit here. So this is exactly is a median for that. So this is what the gradient descent is all explaining all about, and this is in a simple tree diagram form. So after that, uh, so this is the point of the graph which we try to explain what exactly the three-dimensional graph, and this is a four-dimensional bigger where if we try to jot it down, when we can clearly explain how much the difference is quoting all about. So that's the end for the today's session of CNN and I would like to also explain about the computer vision. Computer vision is nothing but looking at the data from the camera's point of view and getting and trying to convert the data into stochastic gradient and learning with the help of neural networking. So that is all about the computer vision. It's a just a brief, a very small thing about computer vision. So if you want any further clarification, please. Text me in the comment box stating that you need a better examination about what exactly the computer vision is speaking about and things like that. So that's all for the today's episode. I hope you liked it. If you haven't subscribed to my channel yet, so please subscribe to this channel and please do follow us on Instagram at Edustart now. And if you have any doubt, please feel free to ask. So that's all for the day. Signing off. Bye bye. Take care.